Welcome. This is Coach Dorf. We're in section 3.7 and we're looking at another homework example. In this one, a ball is thrown vertically upward with a velocity of 64 feet per second, and we're given the equation for its position or height as s equals 64t minus 16t squared. And we're asked to find two results to answer two questions. What is its maximum height and what is its velocity when it hits the ground? So let's start with part A. So I'm going to write down the equation s equals 64t minus 16t squared. Now in part A, we're supposed to find its maximum height. So if I think about this, I'm throwing a ball up in the air, it reaches its maximum height and it comes back down. So it looks kind of like a parabola there, which makes sense with this equation that we have here. So what happens when it reaches its maximum height? Well, that means its velocity is 0. So when it's going up, velocity is greater than 0 when it's going up. And when it's coming back down, velocity is less than 0. Right here is where velocity equals 0. And that relates with the derivative, because if this were a parabola, then at that top point there, at that vertex there, you would have a tangent line that would be horizontal and the derivative would be equal to 0. Well, if I take my function s, its derivative is velocity. So when velocity equals 0, I'm at the top point. So in part A, we want to find the velocity first. So velocity is going to be the derivative of this s function, which would be 64 minus 32t. And now we want to find out when that velocity equals 0. So we set that equal to 0. And if we do that, we can solve this and we get that t equals 2. Okay, how do I get that? Some people can just look at that and see that. If not, what you can do is you can take this 64 minus 32t, and I can factor out a 32, because that's what they have in common, and I get 2 minus t, and that's supposed to equal 0. And this 2 minus t equals 0 gives me that t equals 2. Okay, so that's when we have when the velocity equals 0. But what's the maximum height? Well, the height would be putting 2 into the original equation for s, because that s represents its height. So we want to find, so next, find s of 2. So I put that in there. And when I get that, I get 128 minus 16 times 4, which is 64. So that's going to be 64 feet. Let's see, did I do that right? Yes, 64 feet there. Okay, so that's the maximum height. Again, what we did was we found when the velocity was equal to 0, which is, I take the derivative of the s function, set it equal to 0, and I find out that that happens when t equals 2. And then I plug that back into my height function, s, and I solve for that, simplify that, and I get 64. All right, part B. What's the velocity when it hits the ground? So it's going, again, it's going up. As I showed earlier, it goes up. Velocity is positive when it goes up. Here, velocity is 0. And we knew that also this happens when t equals 2. And then as I'm going back down again, the velocity is negative. And the velocity will become more negative as it gets closer and closer to the ground. And we want to figure out what is that velocity when it hits the ground. Okay, so it hits the ground when the height function is 0. All right, so we take our original function s, 64t minus 16t squared, we set it equal to 0, and now I want to factor this. Again, when I factor this, I want to take out what they have in common. They both have a 16t, and I'm just going to take out a negative 16t, and that's going to then give me t minus 4 equals 0. So I take out what's in common because that makes my factoring easier. And now when does negative 16t times t minus 4 equals 0? Well, that means that either t equals 0 or t equals 4. So does this mean it hits the ground twice? No. What happens when t equals 0? Well, that's before you threw it off, before it was projected into the air. All right. And then t equals 4 is when it hits the ground. Also note there's a symmetry here. When you start off, t equals 0, it's on the ground. When does it reach its maximum height? That's at t equals 2 seconds. It would make sense then that when it comes back down to the ground, it would be twice that time, and that would be 4. And so that's what we get, 4 seconds. So that's when it hits the ground. And so now we just need to figure out what the velocity is at 4. So remember, velocity was 64 minus 32t. So velocity at 4 seconds, I'm going to put 4 in for t. And 32 times 4 is 128. So I have 64 minus 128, which would be negative 64 feet per second. Again, notice that it's negative, and that makes sense because it's coming back down to the ground. Hope that helps.